Okay, so when LTP induction occurs, magnesium block is blown out, calcium comes rushing in, an enzymatic cascade is initiated, Krebs is stimulated, Krebs goes and turns genes on. Well, genes make proteins, and those proteins are the changes that occur at the axon terminals in the dendrites that you're seeing in this slide. So what changes? Well, there's increased dendritic arborization. There's more dendrites that form. There's more dendritic bulbs that form. There's more neurotransmitter that's released. There's a more sensitive postsynaptic area. That means more receptors, a larger pre and postsynaptic areas, making it more available for neurotransmitters to release and for receptors to bind to them. Excuse me. Increased interneural modulation. More synapses are formed. Increased shifts. We shift in the firing. So an axon terminal may go here. Well, it shifts over here based on the need. So these are all physical changes that occur to the axons and the dendrites based on long-term potentiation. The physiological changes we're going to call long-term depression. That's the physiology of it. There's also this concept called long-term depression that we don't need to go in, but it's sort of the inverse of that. The point being is when you repeat something over and over again, as if you're studying for a class, you are changing the structure of your synapses to make them more efficient. It's that simple. You cannot learn unless you turn genes on and you change the structure of your synapses. And you do that by the process of long-term potentiation.